Good evening, everyone. Myself, Akash Venkatesan. Today, I will be explaining my machine learning project that is predicting crop disease risks using environmental data and machine learning models. I'm from batch 17, so I'll just explain the problem statement. The thing is, agriculture faces several challenges today, and one of the biggest challenges crop diseases. Uh, which can devastate the yields and also it can affect the food security. So detecting it earlier and prediction of crop diseases are crucial for mitigating the losses and to ensure healthy crops and optimizing farming practices. So in this project, we have developed a machine learning system that predicts crop disease risk based on environmental factors like temperatures, humidity, soil pH, and rainfall. So by analyzing these environmental variables, we our goal is to provide the farmers and agriculture professionals and accurate predictions on the likelihood of disease occurrence, so that it helps them to take a preventive action. So we have implemented the machine learning. We have implemented three machine learning models, basically decision tree, random forest, and support vector machine. So I have implemented decision tree. So I will explain about decision tree implementation in this presentation. So tree is a type of supervised learning algorithm which is used for classification and regression tasks. So what it does is it basically splits the bigger data set into smaller subsets based on feature values. It will create a tree-like structure where each node represents a decision and based on a feature, and also each leaf node represents a prediction. So the reason for choosing decision tree is due to its simplicity and interpretability. So for problems like crop disease prediction, like interpretability is of utmost important. So I will just walk you through the implementation part now. We have done the implementation in Google Colab. So basically, we have the data pre-processing is the first step. So we have used these three data sets for the implementation purpose. And like initially, all the libraries are imported, such as pandas, which are used for manipulation and analysis, and label encoder, which will convert the categorical labels into numerical values, and also smooth, which will balance the dataset by creating synthetic data for minority classes, and also train test split function. It will function is basically used to split the dataset into training and testing splits. So initially the data, all the three data sets are loaded, and then next is renaming of columns will be done. So each data set has column that needs to be standardized. So these part will rename them to have a consistency across all data sets. And the next is add missing columns for uniformity. So here what it is done is for examples in data frame 2, it does not have a rainfall column. So panda.na is added to ensure consistency. And the next step is concatenating all the data sets. So we will be combining the three data sets into a single data frame. So where all the rows from all the three data sets are stacked together vertically. So removing missing values. So basically, the values this will remove the rows that contains any missing values from the combined data set to ensure that the data is clean before training the model. And label encoding, where the label column is encoded as numerical values using label encoder. This step is required for machine learning algorithms to process categorical data. And next is features and targets defining. So like X contains the input features, that is the environmental data, and Y contains the target labels, that is the crop types or disease risks, those things. And next is training and testing splits of data. So the data will be split into training and testing set. So 80% of the data will be split for training, and 20% will be used for testing. And then the next is smooth. Smooth is used to balance the dataset, by generating synthetic samples for underrepresented classes in training set. So once all these done, the function returns the pre-processed and the smooth balanced training set, the testing set also, and also the label encoder. So next, we will see the decision tree implementation. So yeah, here also all the libraries are imported initially, like the decision tree classifier which is used to create the decision tree model, the accuracy score, classification report, confusion matrix, which are used to evaluate the model's performance, and matplotlib and seaborn are the libraries which are used to plot the graphs like confusion matrix, etc. So initially the data is loaded here, like the pre-processed data from the block one is loaded here, and next the model is initialized. So decision tree classifier is a class that creates the decision tree model. So basically random state equal to 42 means this ensures that if you run the code multiple times, the results will be the same. So it controls the data process, random process, random splits in the training data. So it controls that random process. And the next is criterion genie. Like these specifies the method used to measure the quality of a split in the tree. Like a Gini impurity is the default measure for this, and it tells the algorithm how impure a split is. And maximum depth equal to 10 means the tree won't go deeper than 10 levels. Like it will prevent the model from growing too complex. So which will avoid issues like overfitting. And mini sample split equal to 2 means the tree will split node as long as there are at least two samples at the node. And minimum samples leaf equal to 1 means like each leaf node will have at least one sample. And class weight equal to balanced means the data is, if the data is imbalanced, it will make the model pay more attention to the underrepresented classes. Next, the training of the model is done. So these trains the decision tree model using the training data. So the tree learns from the data by creating splits based on features to minimize impurity. And next, once the model is trained, it will make predictions. It After the model is trained, it is used to make predictions using the unseen data. So this will give us the predicted class labels which are stored in this variable. And next, evaluating the model's performance. So these compares the predicted labels with actual test labels. Like basically it calculates the accuracy, which is simply the ratio of correct predictions to total predictions. Next is classification report. So this basically generates a detailed report that will include precision, recall, and F1 score for each class. These metrics help you understand how well the model is performing for each class individually. And also the confusion matrix is plotted. Like confusion matrix is nothing but a table which is used to evaluate the performance of the classification model by showing the number of correct and incorrect predictions broken down by classes. So it's basically that. And I will just execute the decision tree model now. First I will be doing this data pre-processing. It is executed successfully, and next the decision tree model we will be executing now. It is executed successfully, and below is the output for that. I will just expand this output. Yeah. So basically the accuracy of the decision tree is 76%. So it means that the model correctly predicted 76.6% of the instances in the train set, in the test set. So in the classification report, we like the value, the things such as precision, recall, F1 support values will be there. Precision tells us like how many of the instances that were predicted as a particular class were actually correct. And recall is nothing but it tells us how many of the actual instances of a class were correctly identified. And F1 score is nothing but a harmonic mean of precision and recall, and provides a balanced measure. So basically, if F1 score is high, the model is balancing both precision and recall effectively. And support represents the number of instances of a particular class in the test set. So for example, for cotton, the support is 21, meaning there are 21 instances of cotton in the test set. And bottom, if you see, there are macro average and weighted average. Macro average means that gives an equal weight to each class, like meaning it calculates the average precision, recall, and F1 score without considering the class imbalance. So these are the scores for macro averages. And next is weighted average, which means it takes into account the number of samples in each class to calculate the average. This means that the classes with more samples will have a larger influence on the average. So this is the classification report. Next, I will show you the confusion matrix. So this is the confusion matrix, and basically the row represents the actual crop labels, and the column represents the predicted crop labels. and diagonal values will be representing the correct predictions. Like for instance, 20 for Apple means like all 20 were predicted correctly, and like off diagonal values means it is basically denotes the misclassifications. Like example 6 cotton examples misclassified as a maize. So that's what off diagonal values are. So this is basically the confusion matrix. And at last we have implemented the so other models execution, and at last we have implemented the performance metrics comparison graph, like which basically shows the latency, throughput, accuracy of all the three models. So if we see for decision tree, the accuracy is 0.76, which is rounded out to 0.77, and also it performs well in terms of latency and throughput. Like the latency is really less, 0.002 seconds, and the throughput is also really good. The only issue is that like it shows some delay in classification precision. So otherwise, decision tree performs well. So yeah, that's it for the presentation today. Thank you so much.